We have another example on the board. This time we are going to solve this problem without redrawing the diagram. First, you're supposed to look what we have given on this diagram. Please notice that we have given voltage across resistor R1. Okay, this is very important information for us because resistor R1 is connected across the voltage source, means it's in parallel with the voltage source. So it means that because this is parallel circuit, right? I'm talking right now about the voltage source in resistor R1. So I can write that V1 is equal voltage source, which is equal 30 volts. Okay, this is equal sign. So we've found the voltage source. Okay. Next, if I have voltage source and I have I total, I can find the total resistance because R total is equal voltage source over I total. Voltage source is equal 30 volts over I total 15 milliamps. This is equal 2 kiloohms. Okay, so this is the total resistance of my circuit. So we have R total. Next, what do we have next? We have current I3 and we have voltage V2. The current I3, right, is the same current which will go through resistor R2. Why? Because these two resistors are in series. So I can write that I2 is equal to I3, and this is equal 4 milliamps. So we found I2. Okay? Now, because I have current which goes through resistor R2, I can find the resistance of that resistor. So I'm supposed to use Ohm's law. R2 is equal V2 over I2. V2 is 10 volts over 4 milliamps. So R2 is equal 2.5 kiloohms. So we found R2. Next, you're supposed to realize that the voltage drop across resistor R2 added to voltage drop across resistor R3 will give me voltage source. Why? Because these two resistors are in series. This voltage plus this voltage will give me voltage source. Let's write this down. So if voltage source is equal V2 plus V3. We have already found voltage source. We have given V2, so we can find very easy V3. So we have to solve this formula for V3. V3 is equal voltage source minus V2. Voltage source is equal 30 volts minus V2, which is 10 volts. This is equal 20 volts. Okay, so we found V3. Now, if we have V3 and we have current which goes through this resistor, we can find the resistance. R3 is equal V3 over I3. V3 we found is equal 20 volts over I3, which is equal 4 milliamps. This is equal 5 kiloohms. Okay, this is value of the resistor R3. Okay, so next we can find the current which goes through resistor R1. Okay, how we can do that? Simply realize that we have two branches. This is my branch 1 and this is branch 2. So because this is my point A and this is my point B, so my total current is going to split into two currents, right? Current I23 and current I1. I know already current which goes through these two resistors, and I know I total, so I can find I1. So just keep in mind that I total in this case is equal I2, we can say, instead of saying I23 or I3, we can just write I2 because this current will go through these two resistors. So no matter how you are going to call it, you are going to call I2, I3 or I23 is the same thing. So if I total is equal I2 plus I1. In order to find I1, I have to solve this formula for I1. Okay, this is nothing else, just Kirchhoff current law. So if I1 is equal I total minus I2, where I total is equal 15 milliamps minus I2, which is equal 4 milliamps. This is equal 11 milliamps. So I know the current right now which goes through resistor R1. I know the voltage, so I can find very easy the resistance R1. R1 is equal V1, right, voltage across resistor R1 over I1, where V1 is equal 30 volts over I1, which is equal 11 milliamps. This is equal 2.72 kiloohms. Okay, so this is the resistance of the resistor R1. So we found I1 and we found R1. Next, we can find the total power. P total is equal I total times voltage source, where I total is given is 15 milliamps times the voltage source, which is equal 30 volts. So total power is equal 450 milliwatts. Okay, so this is the total power in my circuit. Power at resistor R1. I'm going to calculate using the formula P1 is equal V1 square over R1. V1 is equal 30 volts raised to the second power over R1, 2.72 kiloohms is equal 330.88 milliwatts. Okay, so this is the power at resistor R1. Next, I'm supposed to find the power at resistor R2. So if P2 is equal V2 raised to the second power over R2, which is equal, V2 is 10 volts, this is given, raised to the second power over R2, 2.5 kiloohms. This is equal 40 milliwatts. Okay, so this is my P2. P3 is equal V3 raised to the second power over R3. This is equal, V3 is 20 volts, raised to the second power over R3, which is equal 5 kiloohms. This is equal 80 milliwatts. Okay, so we found the powers at each resistor. Next, we're supposed to verify if our answers are correct. So write P total is equal P1 plus P2 plus P3. This is equal 330.88 milliwatts plus 40 milliwatts plus 80 milliwatts is equal 450.88 milliwatts. Let me remind you that before we got P total equal 450 milliwatts. So as you can see, these two values are very close to each other, so it means that our answers are correct. And I don't know if you realize, but the problem is solved.